Hello everybody, I am Professor J.K. Ray of IIT Kharagpur. Today I like to discuss with you some interesting topic, that is organic compounds containing nitrogen, or you can call it in other way, nitrogen containing organic compounds. Now, organic chemistry is a specialized science. By definition, it is the chemistry of carbon compounds. So, I should say carbon is a must. Carbon is a must in organic compounds. One of my favorite question to the first year students was, can you name an organic compound having no carbon in it? You will be surprised to know some 30 to 40% students answered inorganic benzene, borazine, that sort of thing, but that is totally wrong, because by definition the organic compounds should contain carbon. So, as today's topic is nitrogen containing organic compounds, so carbon is a must. I have shown tetravalent carbon and I have attached it with a nitrogen atom, and we know carbon is tetravalent, nitrogen is trivalent. So, if you now satisfy the valencies with some substituents like hydrogen, the simplest one, the compound end up is methyl amine. This is the simplest carbon nitrogen containing compound, methyl amine or methyl amine. Now, what is the nature of this compound? I mean, is it alkaline or basic? Is it acidic or neutral? How one can tell? Because we know a definition for acid base as per Lewis is a Lewis acid is electron pair acceptor and a Lewis base is electron pair donor. As the nitrogen in this case is trivalent, having a non-bonded electron pair. So, this non-bonded electron pair it can donate. So, it is basic in nature, or let me write down, it is a base. And then question comes, if I substitute some other hydrogen atom with the methyl group, then what will happen? Say, keeping the two hydrogen intact, I put one methyl group instead of hydrogen, and then the hydrogen atom over here. So, this is some sort of molecular weight increase, substitution increase, by which in some way the electron density of the nitrogen atom will also increase. So, if I compare the basic character, this will be more basic than the previous one. Another way, if I now substitute the hydrogen of attached to nitrogen atom by the methyl group, then what will be the structures? If I write that thing, that one of the hydrogen being replaced by a methyl group and the other one remaining intact, then what will be the nature of this compound? Answer is basic. How much? Is it more than the methylamine or less? If we just analyze it little bit, the way I have done for the previous example, that methyl group is an electron donating group, because 3 hydrogen atom attached to carbon will push electrons towards carbon. As a result, the methyl group will push the electron to the nitrogen atom. So, what will happen? This nitrogen electron density will increase, and as per Lewis acid base theory, the capability to donate electron will be more than the previous one. That means, compared to methylamine, N-methylamine will be more basic. And if I now increase one more methyl group into the system, that means N dimethylamine. let me show the electron pair on the right hand side. What will be the nature of this compound? Obviously, it will be the most basic of the three or strongest among these three. Why? The reason being 2-methyl group will increase the electron density of the nitrogen atom. So, the electron density will increase. So, capability to donate electrons also will increase. So, it will be stronger base. Then question come, very interesting question, that is it only the inductive effect which is playing? Is it some other effect which is also helping in the increase of basicity? Answer is yes. We can think about some other interesting features. What is that? Because as per Bronsted and Lowry's concept of acid and base, an acid is a proton donor, a base is a proton acceptor. So, what will happen if this base accepts the proton, and then how the situation will take place. So, let us take this example versus the methyl substituted 1 what we will see when this base picks up a proton. So, it will be now NH2 plus, and next to that this carbon having the hydrogen atom and also a methyl group. What it will do? It will increase the electron density by inductive effect. At the same time, what it will do, that with respect to this nitrogen which is now positively charged, there is a carbon, that carbon having a hydrogen atom directly attached to that. We call this type of carbon is alpha carbon. So, this hydrogen will be called the alpha hydrogen, and if there be an alpha hydrogen, then this hydrogen could be shifted, or the electron pair forming the carbon hydrogen bond could be shifted to the carbon nitrogen system. So, what we can write? We can write another interesting structure where this hydrogen is there, and at the same time the proton loss will take place. There is no bond between carbon and hydrogen atom. So, what will happen? This type of situation is very interesting when there is an alpha hydrogen atom. What is an alpha hydrogen atom? With respect to a substitution from which we are taking that thing, there is a substituent, next to that is the alpha carbon, and any hydrogen being attached to that as the alpha substituent. So, that can help in a phenomena called hyperconjugation. So, hyperconjugation also help to stabilize a species or an ion, and this hyperconjugation is a very interesting phenomena, and that helps because we can write more no bonded resonating structure. I have written a term no bond, the hydrogen is there, H plus is being held over there, but there is no bond between carbon and hydrogen, and partially the bond has shifted, and this type of thing we should write with a double headed arrow, that is symbolized for resonance or electron delocalization. So, electron delocalization is also called resonance, and when one of these structure where we see no bond, apparent bond is there, then we call it as a no bonded resonance, and that also help to increase the basicity of the amines. So, this is also a very interesting phenomena which is found in carbon nitrogen compound with the substituents. Now, let me take a very simple thing. So, we do understand that a simplest compound like methylamine is a nitrogen containing organic compound. It has methyl group and an amine group. If we substitute the hydrogen atoms of the amine group by the methyl group, the electron density increases by hyperconjugation and also by inductive effect, because electronegativity difference is there between carbon and nitrogen. So, the bond being formed between nitrogen and carbon will be shifted more towards the nitrogen atom, and that when being relayed to the next atom, that is called induction, and that phenomena is called inductive effect, and that is highly specified for the electron donating group or electron withdrawing group. We can easily identify by analyzing each bond whether a group is electron donating or a group or atom is electron withdrawing. So, based on that we can write the structure, and we can also calculate the electron density and see that whether a species can donate electron or can accept electron. So, this electron donating phenomena when increases, the basicity increases, as simple as that. Now, I will write another very interesting thing, how to know or how to prepare this type of compound, very simple compound, carbon nitrogen bond. One simplest way to write that thing is an arrow like this. If somewhere we write an arrow like this, this arrow is reserved for retro, means reverse synthesis. So, retrosynthesis means reverse synthesis. I say that if we know how to make a compound, we should know how to break the compound. So, now take it in the carbon nitrogen bond formation. If I know how to make a carbon nitrogen bond, that is the thing I am going to talk about, I should also know how to break that thing and what are the starting materials will be needed to make this compound. So, this type of arrow when being written, that means it is the retrosynthesis. So, if I break this carbon nitrogen bond, I end up with two species, one is a methyl, another is NH2. But question is, this methyl and NH2 is some concept, this is not the actual species or this is not the actual molecule. So, what are the starting material to start with to prepare the compound like methylamine? That means, how carbon nitrogen bonds could be connected with the help of what sort of starting material, what are the condition. Now, this concept of breaking this methylamine to methyl and amine is sometimes called, this species as synthones. Synthones are the concept, not the actual molecule. Why I am telling these synthones are concept, because this from these synthones, by putting something we can get the synthetic equivalent, and those synthetic equivalents are the actual molecule or the starting material, and if we can combine those two starting materials and in under appropriate condition, then we will get back the target molecule. So, I should write methylamine in this case is TM. TM is the abbreviation of target molecule, and these synthones are methyl and amine, because this methyl may be positively charged, may be negatively charged, may be a radical. Likewise, NH2 also, the nitrogen atom may be negatively charged, may be positively charged, or it might be also a radical. So, if I get a methyl radical and amine radical, these are the concept, these are the synthone. If they recombine, then we get the methylamine. Likewise, if I get methyl plus, that is carbocation, amine minus, they can combine plus and minus easily. So, we can get methylamine. If we get methyl minus, then I should have to get that amine plus, and then also it can combine to make methylamine. And there are many other possibilities, like carbon not necessarily will have to be carbanion, carbocation or radical. It might be carbene. Carbene is a bivalent carbon that you know, having a non-bonded electron pair, and this non-bonded electron pair may be spin opposed or spin parallel. So, this type of carbene are very interesting, and sometimes this carbene when being reacted with electron rich nitrogen, when the electron density of that nitrogen is more, we call it electron rich nitrogen. Then what will happen? They will form again the nitrogen carbon bond. So, this nitrogen carbon bond formation could be done in many ways: carbocation, nitrogen anion, carbon ion, nitrogen cation, or carbon radical, nitrogen radical, or taking carbene with electron rich nitrogen, or vice versa. Nitrene is also an very interesting reactive intermediate with electron rich carbon. That means, all the possibilities are there, but the most common or simplest procedure is by taking methyl plus. Why I am taking methyl plus? This is the concept I told you, that this is the synthone. So, what should be the synthetic equivalent? The synthetic equivalent will be putting the negative charge on or connecting it with an electronegative element. Let us take a very good, that is iodine as the electronegative element. So, it will be methyl iodide. Now, it is a stable molecule. I should write this is the starting material 1, SM1. Sm stands for starting material. Likewise, I have to take the NH2 minus, because CH3 plus should combine with NH2 minus to make CH through NH2 methylamine. So, how to get NH2 minus? Again this is the synthone. I should combine it with an electropositive element. That element may be sodium, may be potassium, may be other metals. So, as simple as sodamide when treated with methyl iodide in NH2 with methyl iodide. So, what will happen? The methyl iodide will react with NH2 minus, the counter ion is Na plus. So, this will attack to this carbon and the carbon iodine bond will break. So, we will get some sort of transition state. Remember, I use a term transition state, where iodine is leaving and NH2 is entering the system. So, this type of transition state are not intermediate, TS stands for transition state, will give a product where NH2 is entering from one side and iodine is leaving from the other side. So, this is called an substitution nucleophilic bimolecular or SN2 type reaction. So, what is SN2? S stands for substitution, N should be subscript, but in capital, and 2 should be of the same size as S, not Sn square. Some people say like Sn square, no, it is Sn2. The full form is substitution nucleophilic bimolecular, because in this case the two molecules are sodamide and methyl iodide, and this is a substitution reaction. Iodine is going out, iodide and NH2 is entering. So, it is iodide substituted by NH2 and through a transition state and no intermediate. So, it is a bimolecular reaction. So, substitution nucleophilic bimolecular. So, in this way we are able to make the carbon nitrogen very simple compound, and taking other substituents we can make ethyl, N-propyl, isopropyl, T-butyl, N-butyl, isobutyl, all these type of amine compounds. So, I can write a general formula that RNH2 is the general formula of the alkyl amine. Now, these alkyl amines are very interesting features, because it contains carbon nitrogen bond, and this with this carbon there may be several substitutions, or there may be unsubstituted very simple compound like methyl amine. So, To prepare this compound is very easy, very simple chemistry, even methanol and ammonia could also produce, but basic concept is a simple substitution nucleophilic reaction. I told you that it is not restricted to only this type of reaction, there are several other possibilities. It may be CH3 minus reacting with N plus, but this is the one of the simplest way to make the alkyl amine. Now, I am just doing one more thing over here. I am substituting one of the hydrogen of this alkyl amine with a carboxylic acid group, COOH, rest of the thing remaining intact. So, RCH NH, that means this was there, one of the hydrogen being replaced by COOH. We know COOH is the abbreviation of a carboxylic group, carboxyl, that is carbonyl is CO, hydroxyl is OH, together it is carboxyl. Now, this type of compound, why did I write starting from carbon nitrogen just one substitution of the hydrogen by a carboxylic acid group? Because you know this type of compounds are present in many biologically active compound. One of the simplest compound is amino acid. What is amino acid? Amine group is present and it is also an acidic group is also present. So, amino acids is a very simple compound where the NH2 and COH group both are present in the molecule. So, this is also very interesting class of carbon nitrogen organic compound, or I can say the nitrogen containing organic compounds are very important in everyday life. One of this example is amino acids. What I have written, because this is the normal trick when the carboxylic acid group is a functional group being present, next carbon is called alpha, next to next carbon beta, next to next gamma, in that way we can go up to omega. So, based on that the amino group is substituted whether in the alpha position, beta position, gamma position or delta position, we call that thing as alpha amino acid, beta amino acid, gamma amino acid, delta amino acid, like omega amino acid. So, these amino acids are very important class of compound and this will be called alpha amino acid. And looking at this structure, you can easily guess that this compound is nothing but is simply substituted. If I put R is H, then this compound is CH2 NH2 COOH. And you know this compound is nothing but acetic acids, one hydrogen being replaced by an NH2 group, and this is called the alpha amino acetic acid, or trivial name is glycine. Glycine is a very important amino acid. Likewise, the higher substituted or beta substituted amino acid, gamma substituted amino acid could also be obtained, and those are the building block of another biologically important compound, that is proteins and peptides, and peptides again being linked to polypeptides, that is polymeric things of the peptide. So, in that way one class of compound, biologically active compounds, peptides to polypeptides, all those things are coming under the review or the umbrella of carbon nitrogen compounds, that is nitrogen containing organic compounds. Now, if I write down some of the interesting features of this compound, like if I take say carbon nitrogen, I told you at the beginning that carbon nitrogen bond is a must, and in this case another functionality is being fixed, that is COH, and remaining thing let us put in this case is hydrogen, and of course, I have to satisfy the valency of nitrogen. So, it is CH2 NH2, this is COH, alpha amino carboxylic acid. So, I have rewritten the glycine structure. You look at this nature of this compound. You have a nitrogen atom whose valency being satisfied as 2 plus 2 4 with the 2 hydrogen 6, but this it has a non bonded electron pair. So, what this amine can do? It can donate electron, that we have seen. So, it is a base. At the same time, the same molecule in the other portion we are having a carboxylic acid group COOH. We know acetic acid is acidic in nature, carboxylic acids are acidic in nature. Why? Because if it loses proton, the remaining part, that is COO minus, that is conjugate base, gets stabilized by resonance, and one of the interesting feature of that resonance is we get a symmetrical resonating structure. This is the carboxylate ion which can resonate and can give the resonating structure like this. So, the resonance hybrid should be written in a way that the negative charge is getting delocalized over the whole region. We cannot identify which oxygen is keeping the negative charge for how many time, it is getting delocalized. So, more the identical structure, that is very important term, identical structure, more the stability. We know Kekulé structure's contributions towards resonance hybrid is maximum. So, that sort of phenomena is taking place over here also. The carboxylate ion is getting stabilized by symmetrical resonating structures. Because of that, carboxylate ion will be more stable. So, the conjugate base is getting more stable. So, loss of proton will be easier. So, anything, any species which can donate proton easily will be called an acid. So, carboxylic acids are stronger acid compared to say phenol or other substituted compound. So, that is the reason. So, you have an acidic group, you have a basic group in this molecule. So, what will happen? In the same molecule, one basic group is there, another acidic group is there. We know a very general rule, acid plus base give rise to salt and water. In organic chemistry, we write it in this way: a very simple compound RCH2OH, that is a primary alcohol, being treated with R prime, just to make it different, I have written this structure. And if we treat with a carboxylic acid with a different type of alkyl group, methyl, ethyl, etc., in presence of acid mostly, which not only is a good acid, but also a dehydrating agent. That means, it takes up water. I am giving you a very simple example, little bit of concentrated sulfuric acid is good enough. We end up with a compound that is R1 CO O C2 R. What is this? Now, this compound is nothing but a carbonyl group is there and OCH2R is also there. So, this type of compound is called an ester, ester having sweet smelling mostly. So, this ester functionality is a very important feature for an alcohol and a carboxylic acid. So, alcohol and carboxylic acid when getting mixed together in presence of sulfuric acid little bit, which acts as a not only acidic reagent, but also a dehydrating reagent. So, that helps in the production of an ester, together with some water will be formed, and that water will be taken care of by the sulfuric acid. So, this reaction will be called esterification reaction. So, we understand that when an acidic group is present and a basic group or neutral group is present, they can form an ester like this. But in this case, the point what we have taken, that amine and carboxylic acid group, what they can do, because one basic group and another acidic group. One interesting feature of this is acid is a proton donor, base is a proton acceptor. So, what it will form? It will form a species like this. What I have written? I have written that CH2 COO minus, and with this CH2 the substituent is NH3 plus. What is this? How this is coming from the simple compound, that is glycine? Answer is, as the NH2 group and COH group are in close proximity, one is the basic proton donor, another is an proton acceptor. So, what happens? In this case, the base picks up the proton from the carboxylic acid group, making it a carboxylate, and as I told you that carboxylate gets resonance stabilized in this way, and NH3 plus is also in that way, is quite good. So, this type of features is called Joiter ion or double ion, one positive, another negative in the same molecule. So, one of the interesting features of these amino acids, mainly glycine and other derivatives, are the Joiter ion formation. Joiter ion means two types of ions being formed in the same molecule, where the proton transfer is taking place from the carboxylic acid group to the amine. Amine is accepting it and carboxylic acid is donating it, because by definition Bronsted and Lowry that a carboxylic acid group is a proton donor and a basic group is a proton acceptor. So, this sort of phenomena is very much present in amino acids. I am not going into details of other amino acid, because those are the building blocks of life. In one sense, the proteins, amino acids and peptides and polymerization of that to give polypeptides, all these are very much in the domain of carbon nitrogen containing compounds, or I should say nitrogen containing organic compounds. So, this is one class of compound, but it is not only that. Now, if I write going back to the amine thing, that I have a carboxylic acid group and also I have an amine group, and if I do a similar sort of reaction, let us take by heating that and with the help of some dehydrating agent, the water being taken out from that. The difference of this and the previous one is that this was in ester formation, we had an alcohol and a carboxylic acid. In this case, we have a carboxylic acid group and the amine group in the close proximity and being heated, that means water being eliminated. So, what will happen? This might happen a very interesting phenomena. It can produce a compound like this, where you get a 3-membered carbon, nitrogen, and the third one is the carbonyl group compounds like this. And this class of compounds are very, very important, because I should say this type of compounds, can you name this type of compounds? Answer is yeah, it is a cyclic compound having nitrogen atom in it, and also there have to be carbon in the compound. So, carbon nitrogen containing 3-membered ring. This is the simplest way to describe this, but this is not the only thing by which we are making the carboxylic acid and amine to combine to make a compound like this. There are many other ways, but right now our attention is focused on the amine and carboxylic acid intramolecular reaction. I should say in this way, just to simplify this fact, that OH and one of the hydrogen of the NH2 is leaving as water, and the remaining thing is getting cyclized to make a heterocyclic compound. What did I say? This is the heterocyclic compound. Why heterocyclic compound? Because this is the cyclic compound, no doubt. To make a ring you need at least 3 atoms. Here carbon is 1, another carbonyl is second, and nitrogen is third. So, 3 atoms are there. So, it is a 3-member cyclic compound, and one heteroatom is there in the ring. So, it is the heterocyclic compound. So, definition of heterocyclic compound is now the heteroatom containing cyclic compound. Earlier definition was it will have to be aromatic. Now, it is called the aromatic heterocyclic compounds, which are heteroatom containing cyclic compounds, but they are aromatic in nature also. So, any heteroatom containing cyclic compound should be called as heterocyclic compound. So, from simple carbon nitrogen compound or amino acid, we are able to get a 3-membered heteroatom containing cyclic compound, and this type of compounds having another trivial name, that is called lactam. Ester is one type thing and it is a cyclic ester. Let me put a simple example, CH2OH, COOH, that is alpha hydroxy carboxylic acid. If I take alpha hydroxy carboxylic acid instead of taking alpha amino carboxylic acid, and do the similar thing, instead of taking the amino group, I have taken the OH group, that is the difference, CH2OH, COH, and earlier one was an example of CH2 NH2 COH. This is the difference. What will happen? We can also form a similar sort of compound like this, but this is the difference here is in the 3-membered ring, the oxygen is there as one member. In this case, in the 3-membered ring, not oxygen, but nitrogen is there. So, this type of compounds are called lactam, and oxygen containing compounds will be called lactone, LACTONE. What type of lactone? The carboxylic acid connected to the alpha carbon, which is having the hydroxy group. So, this type of linkage will be called alpha lactone. Okay, so, 3-membered oxygen containing heterocyclic compound having one next member is a carbonyl group is called the alpha lactone, and 3-membered nitrogen containing heterocyclic compound next to nitrogen there is a carbonyl group and other carbon may be substituted or unsubstituted will be called alpha lactam. So, this is the very interesting cyclic compound being obtained from the amino acids. If I take a step forward and write down another thing like CH2, NH2 and I put a carboxylic acid to the beta carbon. From the amino functionality, this is the first carbon is alpha, second one is beta. So, this compound will be called beta amino carboxylic acid. So, if I take a beta amino carboxylic acid and do a similar sort of thing, what will be the product? The product will be CH2, N, CO by the loss of water, and there should be one more substituent. And this class of compound is very, very interesting. This is called beta lactam. Why beta lactam? Because beta amino carboxylic acid's internal salt is beta lactam. This is a 4-membered nitrogen containing heterocyclic compound. And why did I write this thing? The answer is very simple. This type of structure or structural moiety is present in many interesting compound. One of them is penicillin, and you know penicillin is an antibiotic. So, antibiotic activity is because of the opening up of the lactam ring, where the enzyme comes and open up the carbon nitrogen bond, and then this beta lactamase is the enzyme which helps. So, starting from simple carbon nitrogen compound, we are going to the antibiotics. That means, I should say the beta lactamase, monobactam, all these interesting features are coming from simple carbon nitrogen compound, and one of the important field of carbon nitrogen compounds or importance of carbon nitrogen compound is in the antibiotic. You can name many compounds as antibiotics like penicillin, everybody knows, cephalosporin, those are nothing but beta lactam containing. There are some other structural features, but beta lactam is very unique moiety and which must be present in those type of antibiotics, because it kills the bacteria by certain mechanism. So, 3-membered, 4-membered nitrogen containing heterocyclic compounds could be prepared very simple way, and their use in everyday life is tremendous, not only amino acid, peptide, protein, but also the antibiotics. And if I take the amine group being attached to the aliphatic carbon, I end up with this series of compound. If I take the same amine group and attach it to the benzene ring, that is also very interesting feature. Say a benzene ring having an amine group. I did not say anything about the carbon nitrogen bond being attached where the carbon is an sp2 hybridized and part of an aromatic system. And looking at this, you can easily write down that this type of amine, we know this is nothing but aniline. Aniline is simple C6H5 NH2, and this compound interesting feature is it is aromatic in nature, that is it has a delocalized benzene ring. We can write it in better way, not only showing the localized bond, but putting it a delocalized fashion like this, and these two are the Kekulé structure, that is structure number 1 and structure number 2. And we know the contribution of the resonating structure towards resonance hybrid is very important feature. If I calculate, let us take this is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, same thing I am writing over here. And if I calculate the bond order is being calculated by a simple technique, that what is the nature of bond between 1 and 2. Let us take 1 and 2 bond order I want to calculate. In structure number 1, 1 and 2 is a double bond and double bond is taken as 2. In structure number 2, 1,2 bond is single bond and single bond is taken as 1. So, if I add them together, it comes 3 and divide by the number of resonating structure. That means, how many resonating structure we are able to write 1 and 2, because this is the delocalized form, this is not the Kekulé structure, this is overall theme being written. So, this type of resonating structure and their contribution to the resonance hybrid is an important feature, not only to know the nature of the compound, but also to find the bond order, which helps us to do many things. I will explain that. So, when the added sum, that is 3, and how many resonating structures are there, that is 2. So, divide the sum by the number of resonating structure, that is 3 by 2, that is the rule. So, it comes 1.5. So, what is the general bond order of a benzene ring where there is no substitution? Answer is 1.5. How? Because take any position, not only 1, 2, 2, you can go calculate for 2, 3, 3, 4, 4, 5, 5, 6 or 6, 1. You will find alternate double and single bonds. So, in a particular bond, like as I have shown for 1, 2, for double bond it is 2, for single bond it is 1, add them, sum is 3, divide by the total number of resonating structure, in this case 2, it is 1.5. So, bond order is 1.5. So, one important feature in benzene is all the bonds are equivalent, not one larger, another smaller. This is in that way uniform or equivalent. So, 1.5 is the bond order, but if we look more precisely what is the nature of this delocalized structure, we will find there are each carbon atom having the pz orbital, because all these are sp2 hybridized carbon, and this pz orbitals gets with the help of the electron delocalized not only in the top, but also in the bottom. But just to clarify the thing, I can say that you get a hexagonal thing, and top of that or in the bottom of that an electron clouds are there. So, this is overall picture of the benzene ring. Why did I write that thing? Because if you break the aniline molecule the way I did for alkylamine, you will end up with very difficult problem. What is that? Benzene ring as the plus, NH2 as the minus. That is very difficult. Why? Because benzene ring having the electron cloud on top and bottom, which are negatively charged. So, when you bring an NH2 minus to this, what will happen? They will repel. So, there will be no carbon nitrogen bond formation possible. So, in that way what is happening? We will have to look for some other phenomena. That means, carbon nitrogen bond formation by taking benzene ring as the plus moiety or electron deficient one and taking the amine as the electron rich will not do. In other way I can say the nucleophilic substitution or the attack by the nucleophile to the simple benzene ring does not happen. Why? Because electron same electrical charge repel each other. So, electron cloud are negatively charged, and when you are bringing a nucleophile that is also negatively charged, they will repel. So, what is the solution to that? Solution is very simple, that if we take instead of NH2 minus NH2 plus, then the problem will be solved. That means, a positively charged things could make very easily attracted to the negatively charged species, and I will write how this thing happens. But question come, NH2 minus to NH2 plus, that is reversal of polarity, will be very difficult. I will come to that. But if I write a benzene ring in this way, a delocalized system, and I bring an electrophile not NH2 minus, but NO2 plus, then there will be very interesting feature. So, these are the substrates, benzene ring delocalized, NO2 plus, that is the electrophile not nucleophile. So, this electrophile will come very close vicinity of the benzene ring and they will form a charge transfer complex type thing. I can write this thing in this way. There is no full bond being formed, but the electrophile is taking the electron pair which is a delocalized form from the benzene ring to form a complex, rather to call it complex, and this type of complex is called a pi complex. So, a pi complex is being formed by the benzene ring as a donor and nitro group as the acceptor, or NO2 plus as the electrophile and benzene ring as the nucleophile, because it is electron rich. Species, ultimately what will happen? It will form a direct bond with the nitro group, and there will be one of the benzene ring has shifted over there, and there will be a positive charge on the other end. There is a hydrogen over here, there is another hydrogen in this side. So, there will be a direct NO2 with the benzene ring being connected. So, we have got some species where the aromaticity of the benzene ring is temporarily lost. At the same time, a new sigma bond is being formed between the carbon and the NO2 group or carbon and the nitrogen. And this type of, again it is a complex, it is not the stable in that way, it is not a neutral molecule. So, this type of complex is called sigma complex, because a sigma bond is being formed. Then what happens? The hydrogen atom is being donated to make the aromaticity regain. So, benzene ring is now gaining its aromaticity and the nitro group is being directly attached. So, what we see over here from this figure, that if I treat benzene with NO2 plus, I will get a pi complex where benzene ring is the donor, NO2 plus is the acceptor. Then I will get a sigma complex where the direct carbon nitrogen bond is being formed. There is a carbocation in the next carbon, and then by the loss of the proton, the aromaticity is regained and the substrate is being converted to the product. Product is the nitrobenzene. So, this type of reaction is called electrophilic substitution reaction. So, electrophilic substitution reaction is very common in aromatic system. So, I started with aliphatic systems substitution reaction, that was nucleophilic substitution reaction. There directly we went from a benzene, the alkylamine preparation, and in this case we are going from a benzene to the amine by stepwise process. Why? Because amine as such introduction is very difficult. So, what we are doing? We are putting a nitro group, and then after this nitro group is introduced, then we can see that the substitution reaction has taken place. And if I ask you, how can you convert this nitrobenzene to aniline? Look at this. Very simple answer is by reduction. By reduction means by taking hydrogen, especially nascent hydrogen is very good, by tin or zinc and hydrochloric acid will be good enough to liberate nascent hydrogen, which will convert nitro to the amino group. So, to sum up the things what I have discussed now, that nitrogen containing organic compounds are important in everyday life, starting from simple amine basic compound to amino acids, building block of proteins, peptides, polypeptides, to another class of very interesting compound, that is amino acids derived things like lactams, alpha lactam, beta lactam. I did not go to the gamma lactam or delta lactam also, we will explain this thing later. And beta lactam is the structural features present in penicillin, cephalosporin and many other antibiotics. So, these are the very important features of the nitrogen containing carbon compounds or organic compounds, better to call carbogenic nitrogen compounds. And second thing is, aliphatic amines could be prepared very easily from nucleophilic substitution reaction, but at the same time aromatic amines to prepare you will have to go stepwise. That means, put some group which could be converted to the amine very easily. One simple example I gave you is the amine group or NH2 group, and that could be done from nitro by simple reduction, zinc or tin and hydrochloric acid. So, I will continue with some other features of the aromatic nitro compounds and aromatic amino compounds, so that carbon nitrogen bond will be very interesting to get some more interesting molecule. Thank you.